one.
All right. So I think lately there's been a lot of discussion in the data space about, whether or not to go best of breed and add tech to your data stack to enable different types of functionality, or really to look for like a more integrated, holistic solution. And over here at Singlestore, a lot of times we hear that people believe that a unified data platform is a thing of myth, a mythical beast, if you will, sort of like a mermaid or centaurs or Pegasi. I'm not sure what the plural of Pegasus is. But so like what we really need is a combination of features and characteristics, maybe species of data platforms, if you will, or as some people think, a mythical database. So Joe and I know each other for a little while. He knows like I've built my entire career around the fact that such a platform really didn't exist. So spent years building silo data warehouses, integrating operational and analytical systems, doing things like tacking on Redis to improve latency, or Elastic for full text support, and so forth and so on. So I've worked at Google and SAP, and I've built, bespoke data warehouses and BI solutions for people at lots of smaller companies as well. And so, I'm Julie Price. I'm a product manager at Singlestore, and along with my colleagues Bailey and David, I'm here to challenge that thinking and dispel the myth that you really have to have a complex data stack to tackle those complex data problems. So the question then is how? I mentioned that I'm from Singlestore, so you might recognize that Singlestore is really the solution that we're going to bring to you. So Singlestore is a data platform, and it is a unified data platform for data intensive applications. Now, I really want to be specific around that. Like, what does that mean, data intensive applications? You kind of might hear it thrown around a little bit these days. And so kind of the way that we look at data intensity is like thinking about the physics definition of power over area over time. So it's a combination of different factors that determine how intense things are. It's not any one single dimension. And so when you think about data intensity, you think about things like if you need for an operational kind of workload, you need to have super fast lookups or maybe super high concurrency, or be able to ingest data and update data really, really quickly at like high speeds and high rates. Or from a data warehousing perspective, you need to have low latency queries, fast queries, or really large data sizes with aggregations over top. And traditionally, you're using, if not entirely different technologies to do these things. Like when I started out in the data warehousing world, it was, you might be using SQL Server for your operational database and just a different version of SQL Server that you are building your facts and dimensions and you're doing your analysis on, because you don't want to interfere with your transactional processing. Well, a lot of the things that come into play are the way that the databases are set up and things like that. But Singlestore has really found a way to be able to converge that operational processing and the analytic processing all in one. And not only that, but really to actually start to bring in this type of like multi-model type of data processing as well. So as we think about things like doing geospatial processing or full text search, doing time series processing, all of those different types of things a lot of times come into play when you're thinking about a data intensive application. So think about, like a car share service like an Uber or something like that, where you've got to know how the proximity between the rider and all of the different drivers. You need to be able to process kind of what the supply and demand is so you can determine the appropriate pricing and put all of this information together. And it has to happen really, really fast. And in order to do that, people are stringing a lot of things together. But the purpose of Singlestore is really thinking about these type of scenarios where you need to bring a lot of these things together, but don't want to go out and find a bunch of point solutions for each of the different type of processing. And so it's really been built, and we'll talk a little bit about kind of the secret sauce of how it was built with these things in mind to be able to serve these data intensive applications. So I really want to make sure that we talk about the data intensive applications and not really think about it as you're going to eliminate every single other database or data platform that exists that you're working with, and Singlestore is just, the answer to everything all the time. That's not really the intention. It really is for, these type of solutions where you need to bring a bunch of these things together. Also thinking about, if you've got Snowflake in your data stack, and there are just certain scenarios where Snowflake can't handle the concurrency, or it can't get the low latency that you need, that might be a scenario where Singlestore would really help. Or where you've got Postgres or something and you can't scale out as much as you want to, or you don't want to manage the sharding of your Postgres solution, then that's another place where a Singlestore can really help. And then certainly where you have this convergence, where you actually need to have super low latency, super fast upserts, but also be able to do large scale analytics across that data at the same time, eliminating blocking and the types of things that might happen when you're doing the type of transactional processing that often interferes with those larger analytic workloads. And so it all sounds really great, and it sounds like a myth. And so that's what we really want to dispel, is talk about how some of the technology is built so that we can essentially dispel that myth and prove to you. And I think you'll see some cool stuff as we're talking. We'll get to see how it actually works. Okay, so what makes Singlestore unique? First and foremost is the storage. So we've got a patented single table type for both transactions and analytics. Really, we're the only database that enables you to have the single table type for both. And we're really going to dig into universal storage in a minute, because I do think this is really central to the secret sauce of what we can accomplish and how we can accomplish it. A couple of other key things on the slide. And actually, I didn't say this before, but if you have any questions or anything like that, feel free to throw them in the chat. I will also, pause at certain times so you can go off of mute and ask those questions, and we can answer. Or if you really want to reserve them for the end, that's okay too. Some other factors that make Singlestore really unique. We've got the specialized storage, which we're going to talk about in detail. We also have built the query processing engine and the query optimizer for pure speed. So we're talking about the ability to do not just fast transactions, but super fast analytics across very large volumes of data, being able to do super fast query compilation and everything as well. Another key thing that we'll talk about in a bit more detail is this concept of fast ingestion. So when we talk about kind of collapsing a data stack, a lot of times we've got scenarios where we've got data that's coming in through Kafka, and then maybe it's going through another ETL type of solution so that you can do transformations, and it's getting into your data warehouse or database. And then there's some SQL that's happening on top of it as well. Well, we've got something called pipelines, which is an integrated solution that enables you to actually ingest the streams of data, do some processing on top of that data. You can do processing either in SQL or in things like Python or Java or anything really that can compile against Linux, and some other really cool stuff, which Bailey can talk about in a little more detail around integrating things like WASM into the processing engine. And if you're not familiar with WASM, I will let our resident expert talk about that in more detail coming up. And now, of course, it's also really highly scalable, because what good is a data platform these days if it can't scale out, if you can't support huge volumes of data, but be able to do it in a really optimized way and performant way. So we've got unlimited storage that kind of integrates with the universal storage table type, which we'll dig into. We talked about multi-model. So we've got not just only the relational foundation, but we've also got first-class support for document processing, key value type, geospatial time series, full text search. We've got specialized JSON data types and functions for processing all of that information as well. So we can really start to work with a lot of different types of data, do it in a really highly optimized way, and enable you to eliminate potentially some other databases that you might need for serving different types of applications that, to maybe like to build a mobile application, you would go out and get like Firebase or Firestore, or to build, a web application, maybe you would want to think about using Mongo, but we've got the capabilities in Singlestore along with the relational foundation to be able to do that as well. So you really can support these different types of applications in the one place. Singlestore is a cloud data platform, but you don't have to run in the cloud. So there's a, kind of a hybrid ability to have Singlestore on-prem or, to self-manage it on your own. And there's also a Kubernetes operator. You can go out and download what we call our kind of Singlestore in a box, which is just gives you like Docker container implementation of Singlestore for doing testing and things like that as well. So you really can run it anywhere that you can think of. And we've got deep integration with all of like the main cloud service providers. Also, something that's really cool about Singlestore is it was built with MySQL wire protocol compatibility. So the intention was, just to make sure that you could really integrate just about anything with Singlestore without necessarily like going out and doing a bunch of custom stuff. And so it enabled people to adopt Singlestore really quickly because MySQL has a ton of different open source connectors. MySQL and MariaDB are kind of based on the same thing. So they're very compatible. So for the most part, MySQL and MariaDB connectors will work really well with Singlestore, but we also have a number of our own connectors that you can leverage that are, maybe a little bit more highly optimized or provide you with certain different types of features that don't exist in the MySQL and MariaDB ecosystem. But it does help for, really quick, easy adoption. So now we want to dig into the storage, like the SQL secret sauce, what happens under the hood. So Singlestore actually started as a company or a technology called MemSQL. So some folks who haven't heard of Singlestore don't realize that that was the first iteration of where we came from. And what Singlestore or MemSQL was, and kind of the ultimate like initial part of what is now universal storage, is an in-memory row-oriented store. So if you think about, we're all data folks on here, so hopefully you're familiar with the concepts of row store and column store. And this is one of the big reasons why we often have had separation of transactional and analytical systems. So row store is really fantastic for processing transactional type of things, for doing, full row inserts, updates, deletes, full row lookups, like ID style lookups. And what is different about the row store for MemSQL and now Singlestore is that it is all in memory, and it's enabled with a skip list instead of B trees. So B trees they made a lot of sense when, data lived on disk. It was kind of optimized for reducing the IO between disk and memory, but because the data is all in, the data was in memory from MemSQL, we could eliminate B tree and actually use the skip list, which is a really optimal way that you can store the data and then determine exactly where you need to look to get this information. So it really optimized the ability to, to do those types of lookups. It's really optimized for memory, enables super high concurrency updates because essentially skip list indexes are lock free. So B trees are not. So that's a big difference as well, is that you can do these super high concurrency updates, but also get the low latency lookup. So now we're enabling kind of an entirely different type of transactional processing from a write and a read perspective. Now, once we, the data, Singlestore / MemSQL has always been a distributed system. And so we also are able to partition the data across machines, and there's a lot of intelligence around the way that the data gets partitioned and the way that you can access the data that's sitting out, on across the various different machines. And it provides a synchronous replication for high availability as well. So that's kind of like the first starting point for the universal storage. And actually it's like the history of Singlestore, because this is where MemSQL started. Now we layer with that an on-disk copy of the row store, which is column-oriented. And now column-oriented data is really fantastic for large-scale analytics because it eliminates the need to actually process like the entire row of data whenever you go in and just want to see certain columns of data. There's a lot of other benefits that come with it because you can highly compress the data, and we can operate on the compressed and encoded data. And it just really enables like super fast analytics and scans. And we've got different types of like ways that you can continue to optimize this by defining the way that the data is sorted, and by having metadata that gets stored about the max and min that's stored on essentially each partition or each block of data, or segment we call them. And we can do segment elimination. So now where you might have had to process, let's say, I'm just going to use something simple like 100 gig of data to do something in a row store. Now you might just be processing like 2 gig of data. And that's a really simplified way of thinking about it. But that's the benefit that you get from column store. Now, by doing that, we now have the ability to process both super fast transactional type of workloads and super fast analytic type of workloads as well. Also on disk, on SSD, we're storing a transaction log, so you can get all of your replayability and everything that comes with that as well. So it provides that durable storage. So we have, full ACID support and backup and recovery capabilities. So now that's all fantastic, but we're always, abiding by the laws of physics, and this all of the resources that we're talking about here. The RAM that we're talking about for the in-memory row store, and the disk and SSD that we're talking about for the column store and transaction log, they're bound to the nodes or the machines that exist within the Singlestore implementation. So now we wanted to be able to allow people to have just, petabytes and petabytes of data, but not have to pay for SSD, not have to pay for all of the compute that would come along with that. And so we also have a blob store, which gives you an asynchronous replica of all of the data. So you can have massive volumes of data here now, and it can be read by the various different nodes that exist in your Singlestore implementation, your Singlestore cluster. And also transaction logs also get replicated into object store. So now we can do point in time restore from any point in time. And again, we're not kind of bound by the physics of the actual cluster and Singlestore. So these three things together, this like 3-tiered storage, is really what creates our universal storage. And now if you think about what does this mean, it sounds like it's kind of a lot to keep track of and a lot that you have to really think about to make work. And all of this is managed for you. And that's essentially what universal storage provides. I want you to think about it this way. Essentially, when you have your data that's being written into the system, it's always written into this like row store buffer. If you're doing updates, if you're doing deletes, it all ends up in that row store buffer. But we have a metadata system that knows what's in the row store buffer and what's in the column store, and also what's in blob store. And it manages essentially whenever you're making requests of the data, whether it's to write new data, to update data, or to read data, the metadata overall is able to determine, where do you need to read the data from? If you're doing like a delete or something like that, it's not actually going in every time and deleting, because those are really expensive operations. It'll lock up the system, but it's essentially writing a record to the row store that says, I need to delete this record. And now the metadata system says, okay, well, I no longer need to look at that from any part of the storage. And so essentially this universal table type, it has a huge amount of benefit because it really like simplifies that data architecture. You don't have to worry about transitioning data from one place to the other. It reduces your data availability latency. So you're just writing the data and you're immediately able to read it. You don't have to wait for anything to kind of move around. And of course, you can save money because you're not having duplication of data. You can save time because you're not building out these long ETL processes and things like that. And you have a lot of the support for the type of things that you typically don't get in columnar type of systems. So like you have support for unique keys, you have support for super fast inserts, updates, deletes, and upserts, and really fast seeks and really fast analytics all in one. And so that's why our technology is patented, and you can see the patent number if you want to go and look it up and learn all about it. So another really interesting key feature I mentioned is pipelines. So pipelines is streaming ingestion. It's essentially an endpoint that allows you to stream, to like pull different sources for changes. And as they're happening, you can start to bring this data in. It can do both streaming and bulk loading. It recognizes the ability of Singlestore to load in parallel. So essentially it knows exactly what the cluster looks like and exactly what resources are available. So you don't have to worry about kind of scaling up or scaling down. It does all of the resource management that way. And it's totally built in. So you don't have to go out and get some other ETL system to be able to do this type of stuff. It does provide exactly once semantics. So I know that getting exactly once delivery in parallel systems can be difficult, but Pipelines has that natively built in. It's got native integrations with Kafka. So any real version, like any way that you're deploying Kafka, also things like Red Pandas that are Kafka compatible as well. And then all of the various different cloud storages, different types of file systems as well. So essentially can monitor and pull those systems for anything new and bring them in, do any type of processing, either in stored procedures or in other ways. You even can use pipelines to write back out to Kafka. So you can do some processing and then write out to Kafka and also write into Singlestore as well. And we've got support for CSV, JSON, Avro, and Parquet formats with pipelines. One other really cool thing about Singlestore is that we've got some native connectors to some other distributed systems. So not through our pipelines integration, but through connectors that our engineering teams have built, we've got really partition aware or like node aware connectors that work with Spark and Kafka. So they're highly optimized. Like when you think about two distributed systems that are talking to each other, they're really powerful on their own, but a lot of times the connections between them are still single noded. So a lot of times like everything is going through the primary node of a system. And so you've still got this bottleneck that happens. But the Spark connector and the Kafka connector have been built in such a way that actually can recognize all of the different Kafka brokers and kind of align them to the Singlestore partition so that they can communicate directly and in parallel. So you get a much faster integration than you would if you were going through just the primary node. The Spark connector is not only does it provide that kind of a very parallel capability of reading and writing, but it also enables you to do push down of SQL. So it's a native Spark SQL object, and it's very aware of the types of things that will be done like much better and faster in Singlestore. So when you build your data frame and you essentially write a query against it, it's not just going to pull all that data. Like you write Spark SQL, it's not going to pull all the data from Singlestore and try to process in Spark, which is okay at relational processing. It's not really, what it was built for. It'll actually push all of that processing down into Singlestore and just transfer the results, which is going to be way faster, and it's going to transfer them in parallel. So it's just a really highly optimized communication path between two distributed systems, or in this case, three distributed systems: Kafka, Spark, and Singlestore. We also have a huge ecosystem of tools that we integrate with from various different, like all your favorite languages and runtimes and frameworks. So, probably I heard Python earlier. Go, you're going to get to see a really cool example of something that was built in Go. Java, for those of you who like pain, can build some applications in Java and do that really smoothly with Singlestore. It's not the Singlestore Java part that's the pain, it's the Java part alone that's the pain. That's my opinion. Not a huge fan of Java, but we also have native JDBC and ODBC connectors. We've got a native data API. So if you're building web applications, super quick and easy, you don't have to install anything. And, a couple of other cool things that are really big in the data engineering space. We recently just launched our Dbt adapter. So you can build all of your Dbt workflows and do all of your transformations using Dbt and do all the versioning and everything, but have that natively against Singlestore. And, common, BI tools and analytics tools like Databricks and Looker, and even things like MindsDB, we integrate really well with from an AI perspective. So there's lots of stuff on this slide. I'm not going to go through all of them, but, for the most part, your favorite tool, we integrate with it. So how does it all come together? If we think about what we're talking about is really the ability to simplify your data stack to kind of make that myth a reality. And I mentioned before, I'm not trying to say that Singlestore is going to take over for every single database or processor, but really for those data intensive applications where there's a handful, maybe it's two, maybe it's a bunch more technologies that are strung together to meet the processing latency and concurrency requirements you might have. Those aren't the only three factors, but three big factors. And so Singlestore really is often, we think it is pretty much always the answer when you do find that you're kind of like stretching the confines of what you can do with your architecture and you need to bring in other types of systems in order to do that. So just a quick example off of this slide, Hulu, who had Apache Storm and Druid. So, I'm picking one that only has 2 as opposed to one that has 14. The thing about Hulu is that they had 25 hot tier storage nodes, 14 cold tier storage nodes, 26 indexing nodes, 28 nodes for Apache Storm, for Kafka ingestion, and they had Hadoop, Storm, and Druid layers. And they were essentially able to cut their infrastructure in half by moving to Singlestore directly. And they're processing 2 billion rows per hour to do things like real-time video quality monitoring and analytics, real-time content recommendations, and things like customer ad targeting and intelligence. So like ad tech and marketing tech, fintech, like these are all really common types of things that are built on Singlestore because of the types of processing that needs to be done. So I've done a lot of talking, and as they say, the proof is in the pudding. So we really want to dispel the myth by showing you some really cool stuff that has been created directly on top of Singlestore. And so what we have actually is a demo for esports. So anybody who is into gaming, where that esports is kind of this rise of like people professionally playing video games as though, they're like, and people watch them as though they're watching a sporting event. And there's commentators, there's people doing analysis the whole time that gameplay is happening. And what happens is commentators, they might know a lot about the people who are playing, and they might know about the way that they play, but it's really hard for them to look for complex patterns where a lot of events are happening at the same time. And so in order to display like really high quality analytics or provide the commentators with information so they can have some of these cool insights, we need to have real data. And so there actually is a public data set out there that has 10,000 StarCraft 2, like every event from 10,000 games from both sides, both perspectives, like both players. And every game tick is 1/16th of a second. So I don't know exactly what the volume of data is, like in
19 million rows.
So there's 19 million rows. I don't know like what the, like how many gig or whatever it is, but every game take is 1/16 of a second. And what we've done is taken these games and created sort of like an emulator, like a replay of the games, where we're then taking and processing, we're using the game history to be able to process a game that we're replaying and make some predictions about it that can be fed to an announcer. All this is done in Singlestore and Go. There's no other system that's doing it. All of the data processing is done in SQL, and it can be run like absolutely at scale. And so now I'm going to pass it over to Bailey, and bear with us for a second because we need to like handle audio and video and passing all of that off, but Bailey's gonna show you the demo.
And there we go. All right. Hopefully everybody can see my screen. I feel like I'm obligated to say that now on Zoom. So my name is Bailey Hayes. I'm an engineer on our Launchpad team, which is sort of like an innovation team here at Singlestore based in Raleigh, North Carolina. And that's where, I'm streaming to you live. So this demo is pretty cool because I'm a gamer and I love playing StarCraft 2. If you're not familiar with the game, that's okay. I'm gonna try to keep it at a high level. Basically with esports today, there's a lot of money in it. Some of the top tier tournaments will have a cash prize pool of 100 and, easily hundreds of thousands of dollars. I've seen it 1.5 million, I think, for some of the tournaments in 2022. So winning these, very important, but also commentating them is similarly important. A lot of people are watching games on Twitch. And so giving the right amount of data to the esports commentators is also very important. So what we created is sort of a very simplified dashboard that an esports commentator can look at and immediately understand what's happening in the game and make predictions about what's going to happen next. So in StarCraft 2, there are basically 3 civilizations: Protoss and Zerg and humans. And so I'm going to play a game of Protoss versus Zerg. Now let's really check Zoom and see if my audio is coming through.
The matchup everyone loves to see. And in the top right here, our first player in this grand final with.
So can somebody give me a thumbs up if you were able to hear that? Awesome. Okay, great. So what the commentators are doing right now is, they're laying out like, okay, this is Zest. Zest is playing Raynor. We see a couple different styles of game between these two. And one thing to know about these 2 different types of civilizations is the Protoss units are very expensive. And in early game, it's very important to keep those units alive. Right now, what you're seeing on the screen is a bunch of green. And what that's showing is that this is when those units are created. Later on in the game, you're going to start seeing some red, and that means they've been deleted, typically probably because there was some type of skirmish. With Zerg, their units are very cheap. And so there's this type of gameplay that Zerg players usually engage in. And I can jump over to what Zerg's doing right now, like this. And they exhaust units very quickly. They even use some of their units to build new buildings. And so they have a playstyle called a Zerg Rush. And that's fairly common, although pro players typically know how to defend against it. And these are 2 top tier pro players. I'm going to go back to Protoss. The reason why we're playing this game is that it's a pretty fun one to watch, in that it bamboozles a little while the commentators, and then definitely tricks Raynor into not realizing the type of build that Zest is doing. So what we just saw we started with a gateway here. We're going to get a few more of those in this build. Another important key about StarCraft 2 is that it's a lot about managing your resources. So when you see these big gaps, that's typically because they're trying to pull up their resources to reach the right amount of gas. That's this green icon here, so they could build this type of unit, this assimilator, or to collect more gas.
Bailey, the top one is the game that's currently playing.
Exactly.
Right?
Yeah.
What else are we seeing?
So we're seeing the top row is the game that we are replaying live. So we've got a Go process that is pulling from Singlestore and then pushing those events out as if it's happening live. So we're doing a replay, but we're still ingesting those events live. And then from the other side, we're broadcasting those events for serving them up really for my web app. And so basically the next rows are actually games that we think are really similar and they're pretty fun to look at. I'm actually going to pause because, oh, I wasn't fast enough. Yeah. Bummer. Okay, well, he's going to come back, so I'll wait for it. Just know that you'll see these transition as they create different, oh, yes, I got it. Okay. Look how fun this is. So here are my two players, Zest versus Rainer. So that's this top row, but the second row is also Zest versus Rainer. Now, what's highlighted is the person who won. So Zest won in this other matchup, and we're seeing a previous build that was this one in the second row is the nearest one. So what we did is we calculated K nearest neighbors based off of the build composition. A build composition vector that we calculate is basically based off of all the units that they have plus all their upgrades. And then what we're looking at is its change over time at each tick of the game.
So like what is really amazing to me is that this it all happens in real time, like the k-means processing of determining like which games are most similar, and that will change every time something happens in the game, right? And like every 1/16th of a second, there's new data that's coming in, being processed, being considered, and that quickly being output. It's like, I don't know, I haven't seen something that can do this before in my history working with data.
Yeah, so this is basically because we're looking at a huge amount of historical data in real time. So we're both doing things that are, transactional, but also analytical with our K nearest nearest neighbor calculation.
So now we're like Cyan versus Ragnarok. So it's a different, like that nearest game is an entirely different match now.
And so if you want, you can see that a similar game, they created this unit here, which is a void ray. So we haven't seen too many void rays yet, but we do know that Protoss players do have kind of their own version of a Zerg Rush, which is where they go all in on void rays and just kind of totally catch Zerg players by surprise. So I'm going to turn on the audio so you can kind of hear in real time as the commentators recognize that this is happening and then really react to it. And the commentators are controlling the camera, but obviously they can only show one thing at a time. Now, imagine if they know a really exciting event is about to happen, they could get the camera in the right place at the right time. So keep that context in mind while it's playing.
It does slow down the void rays, but allows them to take out buildings, overlords, and roaches incredibly quickly. Extra queens are already on the way for Raynor, and a relatively early evolution chamber. Now, what have we seen most recently? Carapace upgrades very early from Solar in this matchup, so that as he builds his queen count through the mid game, he's able to actually just fight Void Rays head on. He can add the double upgrades, do big Queen Hydra or Queen Ravager pushes. I'm curious to see if Raynor goes that direction, or will he try to go for a more classic +1 melee?
So we just saw a Void Ray, but we missed it on the camera.
Used to mean, certainly. So
we just missed a ton more upgrades that are really tilting the hand that he's about to do a Void Ray rush.
Meanwhile, Zest making one Void Ray.
And there he got it now.
So we have our answer. And just showing the Void Ray and going in. Robo and charge. So Zest playing with expectations here.
Dude, he might even pull off gas here, Zest. Yeah, Zest. Oh my God, Zest is going so hard into this. He's already pulled one guy off gas to build these gateways. This is going to be essentially a gateway all in, and Raynor going melee. I mean, melee Zerglings aren't terrible versus Zealots, but you want Banelings, or especially Roaches would be the best. It looks like Raynor's thinking about Void Rays. You know, that's what we're all expecting from Zest. Play Void Rays, take a third, take a fourth, and he's shown all of these tells to Raynor. He says, look, here's my very early third base. Here's a Void Ray. Raynor with these Zerglings needs to scout. He needs to realize something's up. He sees a second Void Ray. That kind of makes you think, hey, it's mass Void Ray, right? It's a totally normal play. And we don't see any sign of Raynor realizing what's going on. No Roach Horn, no Baneling Nest. Raynor so far has been tricked.
He certainly has. Does that mean he's not going to hold? I mean, signs aren't great, but we don't know until they hit. +1 is going to help these Lings out a lot, but it is still going to be Lings against Zealots, like you mentioned, and that Void Ray giving him a little bit of room to try and get this Prism past the Lings, and he successfully threads the needle there. Rainer just now seeing the Prism.
Okay, he does get a bit
I'm
of
going to
warning.
skip
This is
ahead a little
important.
bit, but
he realizes now he really
one
needs to
thing that
drop
you
a
should have
roach warren.
seen
He's
is
gonna go
that
bailing Aston.
they were about 45 seconds late. And if you're commentating perhaps like a football game, you probably don't want to miss the ball by about 45 seconds, is one example. I'm going to jump a little bit ahead. I know that they hit a game pause at some point in here.
With that many queens, he might actually be able to defend this. The Prism scaring him though, going up towards the main base. The cancel on the 4th has already happened.
The Queens still have a fair bit of transfusion energy, and they go back a ways. There are 4 Queens here. Oh, a pause. Oh my God.
And those Void Rays taking a lot of damage. The Spore does do a lot of damage. That Warpin's going to finish. And that is a ton of Zealots. Remember that Raynor can lose a lot of drones and still be okay as long as he has all those Queens behind the mineral line. Do get surrounded by those Zealots. The Warp Prism survives, Maynard. The Zerglings have gone down. The Queen count is falling. And Zez with a surprise charge it all in. If he gets one more Warpin, that seals the deal.
And he will get it, and he will seal that deal. Zas getting...
Okay, so I know that was a lot of terminology that you might not be familiar with, but if you're a commentator of this sport, you can look at these even incredibly tiny icons and know exactly what is coming next. They're super familiar with them. And so they didn't have access to this dashboard. It's not like the craziest thing ever. It's pretty simple, honestly, if you start kind of like piecing apart what my teammate built, but I think something like this, just the proof is in the pudding, so to speak, of, okay, if we combine these 2 different types of systems and these 2 different types of queries, you can build something that's really incredible that doesn't really exist today as one system. You know, this otherwise I might have created it with like maybe Bigtable and BigQuery at the same time, but I don't know that I would get the same performance.
Yeah, I actually meant to say before, like I spent some time at Google. I tried building something similar to this at Google and was really struggling with, being able to achieve the type of performance. Had to look at BigQuery, had to integrate data and move data into Bigtable, like serving up the type of application with the super low latency that you require. It's just really it's not feasible with one system today, other than Singlestore, at least in my experience.
Some other cool things to highlight is how well we compress data on disk. And just to kind of like show you that I am talking about a decent sized data set, 1/16 of a second across 10,000 games. And those games typically last 5 minutes. You can get some fairly large data by operating on that. And so our query for one of these.
Actually,
yeah,
I'm seeing that correctly. Like none of that data is in memory.
Yeah, a lot of this is on column store. So that's kind of the interesting trick, is that we do have things that are in the games, right? Our row store is going to be our current game that we're playing. And then we're also going to come up with a really, really fast query. That's this one here, for coming up with a distinct game that basically is the most similar game between these 2 points. And so I passed in our game ID and a specific point in the game. And if I look at the visual explain for this, I think you see some pretty interesting stuff. So there's a lot going on. My teammate Carl Sever built this. You should also follow him on Twitter. He's insane. He really worked really hard to kind of get to this point of just sub-second, and in some cases sub-millisecond queries. And so yeah, we're doing a column store filter here across that large data set. But ultimately it gets down to the final query, which is pretty close to we're getting close to the k-nearest calculation, which is not the hash join, but yeah, this build composition vector is the thing that we build up and is ultimately the thing that we're serving up to the web client. So there's a lot we can dig in here. If people are interested, we can answer questions, I guess, probably at the end. But that's That's the like, okay, here's my coolest demo that I have to show people. So
All right, so we are going to hand it off to David. Some may argue that he is not mythical. But all right, so I'll pass it off to David and we'll wrap it up.
Thanks so much, both Julie and Bailey. Really excited to see all the creatures, both the Grogus as well as the StarCraft 2 creatures. It's incredible to see where esports has gone and what's powerful to do with data today. And I think it's just the beginning. And hopefully you've learned some interesting things during today's session, both with the technology built at Singlestore, as well as a lot of open source technology like Go and working with different data ingest systems, perhaps like pipelines and Kafka. We have a lot more to learn that you can discover at Singlestore. We, in fact, have a variety of learning resources. One, if you're a developer today and you want to deepen your knowledge on Singlestore, we encourage you to check out the docs at docs.singlestore.com. We have a full reference library for every SQL command, every custom SQL command, every function, everything in the Singlestore ecosystem, which are now hundreds of commands. These are available in the documentation, both for the cloud first product, which is the demo that Julie and Bailey showed you, which was in Singlestore Managed Service, as well as our on-prem product as well. So one, check out docs.singlestore.com. Two, we do have a community forum where you can learn from your peers. It's at singlestore.com/forum. We have some of our engineers monitoring that, as well as community champions and advocates. So always check out for questions that you may have, and you can discover some gold nuggets from others in the industry. We also have a video series available on YouTube. Some of our developer advocates and evangelists have shared their other exciting data products they've done with tools like Databricks, as well as Spark, Kafka, and other data connectors. So we have a lot of those series on YouTube at youtube.com/Singlestore. If you're looking to also deepen your knowledge with curriculum built in-house from our education team, we do have our learning management system at training.singlestore.com, where we have dozens of courses built from industry experts on developer topics, on administrator topics, on software engineering topics to get started and scaling up how you work with Singlestore. This means anything from working with Docker to working with Kubernetes to working with Python and Flask, Node.js, JavaScript, Go, C#, .NET. We have a variety of courses for pick your language of choice, and you can dive deep into the Singlestore ecosystem. And how Julie spoke about, for example, today about this 3-tier storage, right? We dive deep into that concept about looking at the row store buffer, the column store with that async movement of data, and then to the remote object store. So when you look at all three of those, we have courses that dive deeper into them so you can further master that craft. And beyond the training, we do have a support website. It's at support.singlestore.com. Support.singlestore.com is actually our knowledge base where we have our global support and technical services team that takes some of the best questions from startups, scale-ups, and Fortune 500 enterprise clients, and we anonymize those questions and provide them available for everyone to check out and learn from. Today, that knowledge base is over 200 questions, and this is for everything from our cloud product as well as our on-prem product. You know, what are errors you can see? How can you better tune queries? How can you create the best use case for a connector? So we have a lot of great gold nuggets there for you to check out. And for those of you who are returning to our cloud first product for the first time, we're offering everyone today $500 in free credits on Singlestore. This is for our Singlestore managed service. You can check out the URL singlestore.com/managed-service-trial. You can sign up either with your name and your company email, or direct with Google Connect or Azure Connect as well. So it's a very easy one-click, one and done process for the product. And beyond what we've been learning and covering today, we'll be in just a few moments opening up for our question and answer session, where Julie, Bailey, and myself would be happy to entertain any questions you have on the demo, the product, everything you saw. We have a lot of great events always coming up, and it's not just the event here today. In fact, we have events all throughout the month of March, April, and beyond. You can learn all about them for Singlestore via singlestore.com/events. And some of those upcoming, we have next week, diving deep into how Singlestore powers Uber's surge pricing and looking at that with Forrester. We have later in March looking at fintech applications at scale, such as looking at the cryptocurrency exchanges and how those markets are being powered by Singlestore today. We even have a session on the death of Cloudera and Hadoop and how Singlestore is augmenting those workloads. Yes, I called it here, not first, but Cloudera and Hadoop are dead. We've been calling that for a while. And then in April, how can we partner, building better together? Singlestore and IBM, what does that partnership look like? And it's not always just in English. We're also going global with languages. So we are having in French and other languages how Singlestore is better together globally. So we have a lot of great events. Look forward to seeing you at those. And with that, let's open it up for questions. I'll mention that Singlestore is a cloud-first product. We've received some great acknowledgements, which we're really proud of in the past year, from Trust Radius, in 2022, we received, for the first time in our 11-year history of a company, we joined the Gartner Magic Quadrant for cloud database systems. We were one of 20 databases of over 360 on the market to land in the Gartner Magic Quadrant for 2022 in our company history. So we're really proud of that, and a lot of great moments. So yeah, excited to dive deeper into any and all that. And yeah, let's hand it back over to Joe, and we'll move into the Q&A.
So really quickly, I wanted to mention, if you can hear me okay, all of our Twitter handles are here. So you can feel free to reach out to us on Twitter. You can find us on LinkedIn, or through any of the means that David mentioned. But also a lot of the stuff that we do, we're putting out on GitHub. So everything that Bailey showed you, you can actually go and build yourself on Singlestore with this GitHub repo. So we'll make this link available to you. There's super cool stuff out on the Singlestore Labs GitHub. Want to give Bailey a little bit of time to talk about WASM and some of the cool stuff that we're doing over here in the Launchpad as well. So definitely we'll open it up to questions, and then we can talk about anything data related. Doesn't have to be about Singlestore, but of course that's our favorite topic of conversation.
Cool, thanks everybody. What questions does the audience have?
I'll go with one question. A lot of vendors these days, when you start using their products, there's typically a pretty big trade-off. Usually a trade-off you can accept, but I'm curious, in this case for Singlestore, is there a canonical trade-off that I'm making if I select Singlestore as my primary data store, let's say?
Oh,
Sorry about that.
I was responding, but we were muted. So if you were building a simple application that didn't need scale out, honestly, I would tell you to just use Postgres. I'm probably not allowed to say that, but that's probably what I would do. If it's working for you, then that's probably the right answer. The place where people come to us is when they need scale out in that type of case. And so what I was running there was actually it's one of our S10 clusters, which is fairly beefy to be able to get that performance. If you can imagine that large amount of data I've partitioned across several different nodes, and a lot of the tricks there were part of Singlestore sharding. So if you're not operating across a large data set and interested in really fast ingestion, maybe you don't want to think about sharding. And at that point, then maybe, something like Postgres. That would probably be my first trade-off. Is there another one I'm missing?
I mean, I think just with anything, like when you're adopting new technology, there are some different ways to think about things. And so, again, while we are we are MySQL wire protocol compatible, you might think about the way that you tune things differently. But, a lot of times, like you're trading off sometimes a little bit, if you have a complex use case, if you have a complex scenario, what you're actually trading off is like the need to go and manage sharding yourself and things like that, where instead in Singlestore, you're managing the shard keys, we're managing sharding for you. So like you have to manage your schemas differently. And so you're kind of like trading off one complexity, but having to learn a little bit about, the way to tune this new system. I think also, we're talking about managed service. And so you do, like, we do a lot of things for you, but that to some people is a little bit uncomfortable, not having the control over the way that things, the way that infrastructure is managed and things like that as well. What other trade-offs?
Does that make sense when we talk about shard keys to everybody?
Probably not.
Yeah. Okay. I'm going to share my screen one more time just to show you what it was in this demo. So basically, there's some keywords that you can tell the database, our database engine. Hey, if you figure things out based off of the game ID, you're going to be able to compute really fast about the rest of these queries that are going to be on this part of the data set. It's kind of at a high level what matters. You can kind of think of it like by default, if you have a primary key and you don't specify a shard key, then it's going to be your primary key. So a lot of times that does line up and you don't really have to think about it too much. But in cases like this where it can be pretty complex, I do tend to always specify my shards.
One other thing I guess we didn't mention is that there are, like, in databases that were kind of built from the ground up as purely operational databases, you do have some constructs that don't currently exist in Singlestore, like foreign keys, for example. So if you're really highly dependent on foreign keys for your application and referential integrity is something that you need to have the database control at the moment, that would be a trade-off that instead, we kind of are focusing more on the application managing the referential integrity than the database. That's one thing that I know is something that does come up occasionally, but where a lot of other systems might not have things like primary keys or unique keys, Singlestore does have all of those capabilities. So, like Snowflake has a concept of primary keys, but they're not and foreign keys, but they're not entirely enforced. You can define them in a DDL, but they don't actually get enforced as unique keys. Like we do have that, but foreign keys are one trade-off for sure.
Thank you. Very helpful.
Yeah, my question is kind of related to the question that was posted in the chat, which you probably see, Julie, about seeing if commentators will actually use this technology. But what I'm interested in is, and we've actually talked about this before in other contexts, if you talk to gaming vendors about using this to change their games, of like embedding analytics into the game, because to me, we're talking about commentary, but if the players could see this data, that would probably change their strategy too. Like, hey, this other player is doing this thing. Maybe I should adjust my strategy dynamically in response.
It's like the cheat code without the cheat code.
Right.
Up, down, down. Just kidding.
But if everyone has it, then it's not a cheat code, right? It just changes the nature of the game itself.
Yep.
Yeah. I mean, these are definitely things that we're super interested in getting involved in. Like we're starting to show these to games publishers and things like that. I know from like working with some games publishers in prior life that these are things that are really important. And I think it's super interesting that a lot of publishers are producing games right now that have a collection of like a really significant amount of data and don't really understand how to present it back to the player. And not just for things like StarCraft or for things where you're, battling against somebody else, but just like exploration games and, games like, like role play games and things like that, where you like, they don't want to force you into a particular path, but do want to be able to present information back based on like what you have done in the past and maybe understand like what other players who act similarly to you. These are problems that games publishers are trying to solve. And like, we're definitely working on getting ourselves in to talk to them as much as possible. So hopefully one day you're going to see like powered by Singlestore on lots of cool games.
But seriously though, if anybody knows any gaming companies that I should talk to, please connect me. This is actually the first time we publicly demoed this. And it was really because I just wanted something really cool to show. I do have this like logistics demo that's perfect for what Julie was talking about. And I probably should have done that one because we have a blog post around it. It's really good and goes into a lot of detail about how to use row store versus column store. But right, no, you just can't beat things moving on a screen.
Well, I mean, you have a pretty hard to please audience, and people are saying like definitely the best demo I've seen of a data product. Really like the demo. What else? Great demo, super fun. Right. So I don't know. Congrats. I mean, it's you could do supply chain, but I don't know.
Yeah, logistics.
It's not as cool.
All right.
Yeah, it's just more slow moving. So it's like, here's a boat. It's on the ocean for a month or 3 months or whatever.
So our logistics demo is pretty cool. We simulate 100 times the worldwide shipping logistics on your laptop, and you can speed up the time so that it is moving in real time. Basically, 1 day is 1 second. So that it's all right. It's another one of my teammate, Carl Sever. He built that one too, and his blog post on it is really informative if you want to dig in more.
So the Suez Canal blockage would have only lasted like how many seconds? 14 seconds, 15 seconds, whatever it was, like 30 seconds. So,
yeah,
that's cool. No, it's a fantastic demo though. I do have a question. So modern data stack, popular term. Where does something like Singlestore fit into this?
Yeah, so I think, I mentioned like the name, I think maybe gives a little bit of is a little bit deceiving in the sense of we could, say modern data stack, like it is Singlestore, that's it. But that's not really reality. I mean, we really think of Singlestore as being like complementary to some other things. Like we're, right now we're not necessarily like the transactional foundation of like your ERP systems and like your SAPs and NetSuites and all of these things that like big companies like SAP and Oracle own. And we're really not looking to take out BigQuery and Snowflake and Databricks. Like we're really looking to complement those scenarios where like you have these distinct needs that can't really be served by one of those, or where you're really looking and you're seeing like the modern data stack. A lot of times it looks like this crazy architecture diagram that has, Neo4j and Elastic and Redis and Postgres and, maybe Databricks or Snowflake or something like that. And that we're seeing the modern data stack like shrinking down quite a bit, where we're saying, don't go and get like all of these other things to like accelerate because Snowflake isn't good enough for these particular cases. But, instead, Singlestore is where you can go and you can build these applications with one database. I mean, we're really focused around enabling developers, not necessarily just enabling like data engineers, but enabling developers who are building web applications, who are building analytic applications that previously were going to Mongo and Redis and Elastic or whatever to do their thing. And that's where we drop in. So, we're not trying to take like the super petabyte scale data warehousing. We're not trying to take over data lake. We are really trying to complement where people struggle to do what they want to do without kind of introducing a bunch of like spaghetti architecture into the data stack.
I do want to say that I totally intend to get rid of data lakes, but I
I'm on the Launchpad team. So we're trying to guess what's the future, right? And I just think any data movement that you see anywhere, that can't be the future. The future is petabyte scale all the time, and everything's real time. And you just can't have data movement. And that's where I could talk at length about how I want to solve it. But
well, we should talk offline about this then. Yeah, Matt and I have been talking a lot. We're finishing up the last chapter of our book, The Future of Data Engineering, and this has been coming up a lot, like what's kind of after everything we just talked about. Yeah, we'll have a chat. So this could be interesting.
So Bailey, you want to talk a little bit about some of the cool stuff that you're doing with WebAssembly?
yeah, I guess if you looked at Singlestore Labs, you probably saw a ton of things in there that had the name WASI or WAS or WASM. Before working at Singlestore, I worked with WebAssembly even before it had become a web standard. It became a web standard in 2019. And so it's probably pretty weird to hear about a database company talking about something with the name web in it. And that's really because WebAssembly is neither web nor assembly. It's the thing that we have to say every time we talk about WebAssembly, by the way. I call it WASM, that's another name for it. And basically all the properties of a browser, like taking code from somebody else and running it on your computer, it's got to be sandbox, it's got to be safe, secure, but also because it's your browser, it's got to be fast, and it's got to compile really fast. Well, there are a ton of other use cases that kind of have that same sort of property, especially if you're thinking about user-defined functions and SQL queries. And so what we've done is take WebAssembly runtime and put it in our database engine. And the types of things that enables is like, we were talking about some of the gaps that we currently have, because it's a ton of work to go implement all the different built-ins that all these different vendors have created, like at Snowflake. Now, what I can do is create a WebAssembly module that's got all the built-ins that somebody like maybe Snowflake had. And if I'm migrating from Snowflake to Singlestore, I can import this module, and then I've got all those same functions from before, which I think is just incredibly powerful. That's one thing that makes moving between different databases easier. If more databases do this, that would be amazing. And so that's why I'm participating in like the community group and the Bytecode Alliance, which is pushing the specification forward. I really want WebAssembly to be the next platform for data. So yes, I love that we've got a head start on it, but I really expect more databases to be doing this. And so you can look at ScyllaDB, TIDB, Infineon. It really seems to be catching speed in the data space.
And are we the first database? No.
Syllabitas. We had a PR. I announced it before them, but yeah, they beat me.
Yeah, so that's, cool stuff that Launchpad team is working on. They're they're a research arm, so they're going out and just thinking about all of the things that are kind of the future of data and the future of databases, and really like the future. We definitely believe at Singlestore, like applications, there's not going to be any such thing as an application that isn't like a data intensive application soon in the future. I don't know, like my dad has a company and I just got him to stop using Microsoft Access, but applications are just not going to work with traditional databases. They're not going to work with traditional programming paradigms. We need to be able to expand so we can do a lot more in database, and we can use the resources of the database and make sure that it's optimized. And that's kind of like what Launchpad team is doing. Like they're chasing all the really fun stuff and trying it out and making it work, or not making it work, but then we at least know to kind of shift focus.
Yeah, so imagine your AI and ML workloads, all that compute pushed down to a distributed database. Why would you need a data lake at that point?
How would that work with unstructured data?
So we have support for like semi-structured and blob and cloud data.
Yeah.
And things like that. But if you're thinking about like image processing and stuff like that, we would need to build additional constructs into the database to support it. So, it's not like the immediate future.
Right.
Bailey's got like the 10-year vision. I've got like the 2-year vision.
She's trying to say, don't hold our feet to shipping my stuff anytime soon.
I'm the product manager who has to be held accountable for all of the dates that I specify.
So Julie, when's unstructured data going to be out? I'm just kidding. That's interesting though. I think the WebAssembly is an interesting angle, and it solves potentially. So Matt Housley, who was just talking, we talk a lot about interop and how that's some of the unsolved challenges with data products in general. And perhaps that is a way to solve it. We've been thinking more of a metadata angle, but maybe it's a combination of it. I don't know how you escape metadata, but WebAssembly could help with the interop in the sense where just everything is so the modern data stack is a gigantic mess right now, to be frank. It's there's a lot of vendors, a lot of tools, a lot of money, which means the incentive to actually interop is potentially pretty low, actually, depending on how you want to approach the problem. And so what we expect this consolidation happens. Interop is going to be there's just going to be standards. I don't know how you escape this at some point, just like you have standards in pretty much every industry right now. So, right.
Yeah, I mean, I will challenge that a little bit to say like ANSI standards have existed, like, but everybody has done some type of like ANSI compliance with extension. Like everybody has kind of veered away. There are kind of core standards, but it is hard. It's really difficult. And this is why, one of the reasons why we've built our own native drivers and connectors and not just relied on the MySQL wire protocol compatibility, because everybody veers a little bit away from standards because of differentiating functionality. When you have differentiating functionality, they fall outside of standards, and like other things need to understand how they work in order to interop. So like even, working with things like Dremio or Starburst and things like that, like we are traditional BI tools, we have to be able to extend the understanding. Otherwise we can't support our differentiators. Unless like everything is built the same and works the same, then.
Yeah, it's kind of a question of how does the ecosystem work at some point, right?
Yeah.
So, or does it?
Yeah.
So,
or does some company like invest super heavily in, like you said, creating that metadata layer, which is somehow super performant against.
Well, I mean, I'm expecting this to happen. I mean, at some point, I mean, because it's like, some people have, speculated, certain modern data set companies might be that layer, who knows? But maybe it's just a marketplace upon which everything has to have standardization, sort of like the App Store. And so we're talking about this a couple of weeks ago on our podcast with Nick Schrock, sort of like the App Store bundling versus unbundling was the debate, which is raging in the data community right now for some reason. So, but we like to have echo chamber debates, so it's a ton of fun for everyone. So.
I'll comment. I think it's still the early days, right?
Mm-hmm.
So
yep.
Still, in the early days, we call it the decade of data, right? So the modern data stack's becoming the very modern data stack. And so when we think of this, there's a tremendous amount of tools and players coming out into the space, though we're nowhere near data science as a service. I think only been emerging in the last year or two. The whole data ops becoming DL ops space. I mean, there's just tremendous breadth of opportunity. And, I look at a lot of beyond at Singlestore, like a lot of investments in the space. Also, Joe should get you on the podcast. I run Humane, an AI data science focused one. And we bring on actually a lot of leaders in the ML ops space. We brought in early, Comet and Weights and Biases and a lot of those players. And as we're seeing it evolve, I think one of the conversations I was having earlier today, first off, is the classic debate between open source and do developers want to work with ecosystems with open source tools or closed source tools, and where are the maintainers in those projects? You think to, for example, Apache, right? Traditionally, you'll have the project maintainers, and then you see projects like the drill ecosystem that became Distiller, right? They're now venture-backed company raising their Series A. You see a variety of companies having done that, and there's been talks there, for example, we even saw with Spinnaker and others. And so this is only continuing, but I think it's the early days. And the challenge is going to really be to see what makes better workflows. So I think today it's really about the collaboration. I think it's about better workflows. And I would even go so far to say workspaces, which is a product that we're in early beta for them. I don't know how much Julie or Bailey can talk about today, but
It's coming out next month, right, Julie?
It's not my area of coverage, so.
I can't talk too much about it, but what I'll say is strong believers that the collaboration of the workflow is very important to simplify the modern data stack, to have connectors and integrations easier connect, to simplify the developer experience. And if products can do that, that's where they'll carve out their unique wedges to do very well in the market. And I think that's where Singlestore will carve out, and we'll see that over the next 12 to 18 months emerge.
We actually have a version of our esports demo that uses workspaces. It's pretty cool too. Basically, it's the idea that if you had 1,000 people watching and they all wanted to be streaming this type of data and calculating at these different variable points in the game, say we've provided a service for I want the cheat codes for StarCraft 2, and I want to be able to scrub through and try to make predictions about me versus the other players. Well, right now, if you look at my system, I'm maxing out the CPUs in places to be able to run that in sub-second, in some cases sub-millisecond. But yeah, anyways, it's pretty neat because you just kind of like spin up another workspace and attach it to your compute. And so that way it also makes it a lot better, I think, for trying to come up with like your billing parts of it, which I can't talk a lot about that. I'm on the Launchpad team. I'm in fun money land, but that does seem like something else that's very important for coming up with your compute.
Interesting. What other questions does the audience have? You can ask really crazy things too, so you've kind of already gone there. So. Nothing? Gosh.
Well, hey, if you guys want to go and spin up the demo yourselves, you can check out the trial on Singlestore Managed Service and check out that GitHub repo. We'll make sure that everybody gets the link and some of the other information about. I think we can make the slides available to you, and that'll have all the links to all the training stuff and everything. And like I said, feel free to reach out on LinkedIn or Twitter. Go find Carl on Twitter and just like harass him about Singlestore, and you will learn everything you ever wanted to know and more. And so that's super fun. He's the one who built the demo that Bailey showed. But we really appreciate your time today, and thanks, Joe, for inviting us to come and chat with you. And for anybody who noticed that Jordan Tagani was on the thing, he was supposed to be here, but he got pulled away to something. So I am, so that's why we are not Jordan, but hopefully you still enjoyed our talk.
The combination of us three, maybe we got close enough.
Well, I'll stop recording. But thanks everybody. Great questions, great demo. Like I said, this is I think a lot of people unanimously agreed, like probably the best demo we've had. So congrats on that. That's a lot of demos actually, when I think about it. So but I'll stop and then we can